All right, so there's 3 different types of in behavior. The first one is when it's balanced. Balance means that it's the same degree, top and bottom. In behavior is the same as the horizontal asymptote. That's what the in behavior represents. This is the horizontal asymptote. Okay, so there's 3 different types. The first one is when it's balanced. If it's balanced, that means that you have the same degree in the numerator and denominator. Does everybody remember what a degree is? How do you find the degree? How do you find the degree of a function? What is the degree? It's the highest exponent. So if the highest exponent on the top and bottom is the same, we would divide the leading coefficient. So an example would be y equals 3x minus 5 over x plus 2. Notice that they're both first degrees. So this would be a first degree, and this is a first degree. And when that happens, we simply divide whatever number is in the front. Which means for this example, it would be y, your horizontal asymptote would be at y equals 3. If you have any questions as I go through this, because there's only 2 days or 3 days of actual teaching, and then we are going to review and take a test. As we go along, if you have questions, please ask that question. So the first option would be that it's balanced. Second option would be top heavy. And that means you have a higher degree in the top. Or in the numerator. When that happens, that's the only one that's it requires a little bit of work. Okay? When that happens, the horizontal asymptote is a slant. And your equation is going to be written as y equals mx plus b. So let me give you an example. We have y equals x squared plus x minus 3 over x plus 2. That's just an example. Again, notice that we have a second degree in the numerator and a first degree in the denominator. So we call that top heavy. When that happens, we have to use synthetic division. This is the only one that takes a little bit of work. To find the equation. So what we would do, if I use my example, set this equal to 0. And what is x plus 2? If you set x plus 2 equal to 0, what do you get? Negative 2. So I will put this on put that number on the outside. And then I would list my coefficients in the numerator. So that would be a 1, a 1, and a negative 3. All right, do we remember how to do synthetic division? How do we do synthetic division? What do we do first? Bring down the 1. Then I would multiply 1 by negative 2. Put that here. Go ahead and add. What is 1 plus negative 2? Negative 1. These two numbers represent the slope and the y-intercept that I need in my equation. So if this was an actual question on your test Friday, you would say that the horizontal asymptote is at y equals 1x minus 1. we would actually have to graph that. It would be a slant. So instead of it being just horizontal, it's gonna have a slope of 1. It's gonna be slanted. So we talked about balance, we talked about top heavy, and the last one would be bottom heavy. Bottom heavy is the easiest of them all. If it's bottom heavy, that means it's higher in the bottom. I mean, kind of self-explanatory, but higher in the denominator. So what I'm going to do is just take that example from before and just flip it. Okay. When that happens, that's the easiest because we don't have to do anything. It's automatically the same thing. Our horizontal asymptote will just be at y equals, does anybody remember? 0. So that's the easiest one. There's nothing to do. It's just y equals 0. So we're only going to do 3 graphs today. We have 8 graphs in total that we're going to go through. We're going to do 3 today, 4 tomorrow, and then the last one Wednesday. So I'll give you a second to copy this down. Go ahead and get your notes situated. Glue down your first sticker. Again, I do not have extra stickers. If you lose those, then you just don't have one. And I'm going to also talk about end behavior. So I'll give you a second to get your graph set up. Let me see if I can get in Skyward from my phone. All right, so let's get it. So first thing first, remember that roots and y-intercept, both of these are both ordered pairs. I don't really have enough space to say this, but both of these are ordered pairs, not equations. A root is the same thing as an x-intercept. So in order to find your root, you're going to focus on the top. This is not a special case because it's just one fraction. We don't have a number on the outside. It's just one fraction. So I want you to take the top, which is x minus 4. Set that equal to 0. And then you're going to write that as an ordered pair. So if x minus 4 equals 0, what does that mean x is equal to? 4. So my root or x-intercept is at 4, 0. This is how the questions will be asked on the test. Root, y-intercept, vertical asymptote. It could say in behavior, which is the same as horizontal. Same questions. Okay, let's go ahead and plot that on our x-axis. That's the only place the graph should cross x is at 4. The definition of y-intercept will never change as long as you are alive. It does not matter what kind of function it is. To find your y-intercept, you substitute in 0 for x. So that would be y equals, and then plug in the zeros. And again, that's an ordered pair. X is 0. Go ahead and figure out what y would be. So you're going to take 0 minus 4, which is the same thing as negative 4, and divide that by 0 plus 2, which is 2. So what is negative 4 divided by 2? Negative 2. Good job. Again, that's an ordered pair. Go ahead and plot that point. Okay, these two, both of these are equations, not ordered pairs. For your vertical asymptote is x equals, and for your your horizontal asymptote is y equals. Okay, vertical asymptote, that comes from your denominator. So when I take the x plus 2 and set that equal to 0, what do we get? X equals what? Well, what did we say? Negative 2, yep. So let's go ahead and graph that in. I like to use a highlighter. Feel free to borrow a highlighter. I have highlighters in the front. I also have red pens on the back. It's not required, but I just like to put mine in different. So I'm going to draw in a dashed vertical line at y equals negative 2. Did I say y equals negative 2? At x equals negative 2. I'm sorry, I'm still not awake. It's going to take me a couple of days to get back into the swing of things. I feel like I should make that a little skinnier though. Okay. Going back to what we talked about before. What kind of function is this? Is it balanced, top heavy, or bottom heavy? Balanced, because they're both first degrees. This is both first degree. So when that happens, you simply divide whatever that leading number is, which in this case is 1 and 1. So your horizontal would be y equals 1 over 1, which is simply y equals 1. So I'm going to pick up that same highlighter and draw in a horizontal asymptote at y equals 1. There are we don't have any quadratics. Nothing cancels. Okay, so this does not have a removable discontinuity, so I'm going to say that is NA. So I'm going to go ahead and draw this in. I have enough on the right side, so I'm just going to come in close to that horizontal asymptote, make a slight turn, and then go straight down next to the vertical asymptote. So we don't have anything over here. So we need to pick a couple numbers over here. So I'm going to make my little T-chart. I'm definitely going to use -3 because that's probably going to give me a whole number because it's right next to the vertical asymptote. And then I'm going to pick another number. I think I'm going to go with -7. But last period we used -10. 10, it doesn't matter. We can use anything. So let's go ahead and substitute that in. So for my first one, it would be -3 minus 4 over -3 plus 2. See what you get. For my second one, it would be -7 minus 4 over -7 plus 2. So go ahead and use your calculator. The second one is probably going to be a decimal. You need a calculator. I thought I saw one on the floor. I guess I didn't. All right, let's go ahead and see what you get. All right, I don't have a calculator, but -7 should be 2 point something. 2.2? Okay. Let's go ahead and graph those. So -3, 7, I'm going to put a point. And then at -7, I'm just going to put it at at 2. 2.2, close enough. Go ahead and draw that out, and that would be your graph. So in behavior, again, is what is happening on the ends. Like that's what we're trying to figure out. Now the ends are right here. This right here, these two purple highlighted arrows. What are those two purple highlighted arrows doing? Are they going up? Are they going down? Or are they going out straight? Straight, right? Does everybody see that? And what is the Y value? This is the Y value that it's approaching on both sides. And what is that number? Where did I draw in my horizontal asymptote? 1. So you would say your limit as x approaches positive and negative infinity for f of x is 1. Okay, go ahead and copy down the next one. Go ahead and get it all set up. Again, we got the end behavior at the bottom. I'll give you a moment to set up your second graph. Then I'm going to run into Skyward real quick and try to do attendance. Hopefully it's not down. Okay. Oh, what's going on with my iPad? Post attendance. Okay. So this is a special case. The reason why it's special is because of this -2. I have a number outside of the fraction. So when that happens, it affects how we do two things, the roots and the horizontal asymptote. So now that it's a special case, I can't just look at the top. I have to set it equal to 0 and solve it. Is that somebody knocking at the door? So let's go ahead and do that. So let's go ahead and solve that for x. So what's the first thing I'm going to do? Add 2. So I have 2 equals x over x minus 3. And then I'm just going to cross multiply. And that would be 2 times x minus 3 equals x. Distribute. All right, go ahead, take it from there. Solve it for x. Do you need graph paper? That's for this whole year. Oh, you didn't get one. All right. What did you all get when you solved that for x? I'm going to subtract 2x from both sides, which will give me -6 equals -1x. Go ahead and divide. You get x equals 6. So I'm going to write that as an ordered pair. Go ahead and plot that on the x-axis. All right, now let's find your y-intercept. We're going to substitute in a 0 for x. Any questions over this before I erase this? Okay. All right, to find your y-intercept, I'm going to substitute in a 0 for x, so that would be y equals, and it would be 0 divided by 0 minus 3, and then subtract 2. So this fraction is 0. Do we all agree that 0 divided by anything is 0? Do we agree with that? And then we just need to, we can't ignore that -2. That's why it's special. So 0 minus 2 is -2. So that means our y-intercept is at -2. Let's go ahead and plot that point. The vertical asymptote will always come from your denominator. So if you set x minus 3 equal to 0, you get x equals 3. I'll go ahead and graph that. This is also balanced. So we're going to divide these two. So that would give us y equals 1 over 1, but then we have to include this minus 2. So essentially, it's y equals 1 minus 2. And what is 1 minus 2? Negative 1. I'm going to go ahead and draw that in. And that would be here. Nothing is going to cancel. I don't have any quadratics, so this graph does not have a hole. That is NA. So we need to add in a couple of points, and I think I would probably choose the points that are close to the vertical asymptote. So let's substitute in 2 and 4 because we don't have anything close. And those numbers are generally a whole number. So that's what I'm going to use. I'm going to substitute in 2 and 4. So for the 2, it would be 2 divided by 2 minus 3 minus 2. This will be 4 divided by 4 minus 3 minus 2. So take a moment and substitute that in. See what you get. So we got 2 divided by 2 minus 3. And then we need to subtract 2. And then we have 4 divided by 4 minus 3. And we need to subtract 2. Okay, so what did you get for the first one? So that's negative 2. So is it negative 4? All right, and for the second one, I think that's positive 2. Is that what you all got? All right, let's go ahead and graph them. So at the 2, I'm going to go down 4. And at the 4, I'm going to go up 2. And remember, all we can do is follow the guide of our asymptotes. So when I draw my graph, it's going to come in really close to that horizontal asymptote, make a slight turn, and go straight down. And on the right, it's going to come in really close to the vertical asymptote, make a slight turn, and go straight out. The limit as x approaches plus and minus infinity of f of x is what? What's happening? What's on both sides is going straight. And what is it going straight towards? What's the y value that is going straight towards? I heard it. Negative 1. Who agrees? Negative 1. Okay, I'm not giving me much today, but that's okay. It's the first day back. Well, 6th period is usually my quiet class, so that's okay. All right, we only got one more, and then we are done for today. And then I will show you your tests. Now, I am going to have you write down the next one so that tomorrow you're ready to go. But go ahead and copy this one down. Oof, I knew I was going to run out. 4, 5, 6, 7, 8. So when you see this on the test Friday, the first thing you should do is factor. So I'm going to factor mine down to at the bottom. So if you factor x squared minus 4, you get x plus 2 and x minus 2. Difference of squares. If you factor x squared minus 2x minus 8, you would get x plus 2 and x minus 4. So what factor can I remove? X plus 2. So that means that we're going to write this. This is an ordered pair. Since we're canceling that out, that means we are removing it. If you take x plus 2 and set it equal to 0, you get that x is negative 2. Now, for the rest of my questions, I am going to use, I'm not going to use this one anymore. For all of the rest of my equations, I am using y equals x minus 2 over x minus 4. So what I want you to do is substitute in negative 2 and see what you get for y, for your removable discontinuity. So that would be y equals negative 2 minus 2 over negative 2 minus 4. And feel free to write that as a decimal. So just because of time, I'm going to have to help y'all out a little bit. So we got negative 4 over negative 6, which is going to simplify down to 2/3, which is the same as 0.6. So I'm going to put an open circle at negative 2, 0.6, which is going to be about right here. I'm going to make it pretty big so I don't forget it. That's a removable discontinuity right there. Everything else is just like before. To find your root, which is your x-intercept, take the x minus 2, set that equal to 0, and you should get 2, 0. For your y-intercept, substitute in 0 for x. So that would be 0 minus 2 over 0 minus 4. Which is going to be a half. So I'm going to write it as, you can write it as a fraction or a decimal, it doesn't matter. Vertical asymptote comes from your denominator. X equals. So you're going to take that x minus 4 and set that equal to 0. If x minus 4 equals 0, what does x equal? 4. I'm going to pick up my highlighter and draw that in. Dash line at x equals 4. And this is balanced. Even before we canceled it, it was still balanced. It was a second degree over a second degree, which is balanced. But now it's a first degree over a first degree, which is still balanced. Because it's balanced, we simply divide these numbers. Y equals 1 over 1, which is just y equals 1. Okay. Oh, so we got that in. So now we just, oh, I didn't graph my ordered pairs. Wait, let me put, I'm like, how come I only have 1 point? Because I didn't graph my y-intercept. So my y-intercept is at 1/2, so that's about here. And then my x-intercept is 2, which is here. So now we got that. I was like, we should have more than just one thing on the graph. Okay, so I'm going to come in. I start off really close to my horizontal asymptote. I hit that removable discontinuity. I jump over it, and then I hit these two. I get really close to the vertical, and I just go straight down. We don't have anything on the right side, so we need to do a table. So I'm going to use 5 and 8. No reason why, I just picked them. So we got 5 minus 2 over 5 minus 4. Then I have 8 minus 2 over 8 minus 4. So that's going to be 3 over 1. So 5, 3. And then that's going to be 6 over 4, which is 1.5. Right? Yes. All right, so 5, 3. And then 6. Wait, is it 6? No, it's 8. 8, 1.5. 8, 1.5. All right, so it's going to look like this. And that would be my graph. The limit as x approaches plus and minus infinity of f of x is what? What is my graph doing on the ends? 1. And that is everything.